Hey everyone, I'm Victoria. Thank you for having me, and I'm really excited to talk about Databricks being frozen over, bringing the best data catalogs and Apache Iceberg together in one place, offering a great data platform. So, I'm Victoria. I work in the product organization here at Databricks. And before Databricks, I was actually at Tabular, where we built a data catalog for Iceberg tables as well as a bunch of services to help maintain and have high quality Iceberg data sets. So my plan today is I'm going to talk a little bit about data catalogs. Databricks is data catalog, Unity catalog, and Iceberg at Databricks. So I think everyone here is familiar with data lakes or data lake houses. And I want to talk a little bit about the messy realities of what our data platforms may look like in the context of data catalogs. So, does your data lake look something like this? So, you may have several different applications that will be writing data to object storage. You may call this layer your bronze layer. So, we have unprocessed data that's coming in its rawest form that will need to be processed later on. So this data could be in the form of like Parquet data, maybe they are actually like Iceberg tables or Delta tables, but they could also be JSON files and CSV files. I like to call those our structured data sets. Then we have semi-structured and unstructured. So these could be, log files, but even audio, images, videos, all of those sort of data sets and pieces of data, you're probably storing in object storage and then using them, processing them, using them with various different engines and tools for your analysis. So we have files and object storage. We have multiple applications wanting to access and process that data for a variety of use cases, data engineering, ML, reporting. But when we zoom into what the data looks like in object storage, it may look something like this. So you have a bunch of directories, maybe you have specific tables, directories that have like your Iceberg tables, your Delta tables. You have a directory for your images, what kinds of images, maybe you have a car folder with all the car data. And now the question is, how do you and your data scientists, data engineers in your organization discover this data? How can we figure out and manage the access to this data? Who has access to the data? But more importantly, the observability aspect, who is accessing it and when and how? And then with all of that put together, we're discovering data or accessing it. Maybe we're transforming it to build these silver and bronze data sets. We want to understand the lineage of how a downstream data set is produced. So lineage is pretty important. So there's a lot of moving pieces here. And when we talk about data catalogs, the one that probably comes to most people's minds is Hive Metastore. And it solved a few problems for us. So one was the discovery. So you didn't need to know like all the different directories or even buckets your data would live in. We could tell Hive what tables exist and how to access that data. So for example, I have this picture here where you can see the location of the data. We see the format of the data and even the schema. So an engine can come in and say like, read this table, read Hive raw car images. And it would be able to read this information from Hive and figure out how to interpret the data from object storage. And we could also use this to then manage IAM permissions. Does my application have access to this data, or this user have access to this data? So it helped solve some problems for us. Now, what about data catalogs in the context of Apache Iceberg? We're at a Iceberg meetup right now. Iceberg, I find it really hard to think about without the context of a data catalog. A catalog is actually quite integral to the Iceberg spec, and it's gone through a little bit of an evolution. So we have, probably most people don't remember this, it was short-lived, but you can actually use Hadoop or a file system as the base of a catalog. So you could do something like this, where you can load an Iceberg table and give it the path this will look for that metadata.json file that I like to call it the ledger of the table, but it can figure out what is the latest version of that file and load the table. We have what most people, I think, use in terms of like legacy usage of Iceberg is Hive or some sort of relational database. So like Hive, JDBC, there's Nessie, there's Glue. And I think in this category, what happened was there's actually an Iceberg catalog interface, and anyone could go ahead and implement that interface and start offering libraries of how to integrate their catalog. So you had to import these libraries to figure out how to interact with the catalog itself. And in this version of Iceberg catalogs, what's being stored in the database is usually just the pointer to the metadata.json file. And in the case of Hive, the way that this would work is you would say, I publish a bunch of changes. Everything in that metadata and data layer of the diagram, the client would write out. It would say, I've done all my work. I go to Hive. I ask for the Hive lock for the table. I grab the lock, see if my changes are compatible. If they are, I write the new metadata.json file and commit it to the table and release the lock. So through this locking mechanism, we were able to resolve concurrency problems and have like atomic transactions. Now there's been this new evolution to Iceberg REST, and I could probably do a whole presentation just on like Iceberg REST catalog. So whenever you hear like IRC, it stands for Iceberg REST catalog, and it's this category. What's happening is there's no actual implementation of this in the Iceberg repo, but what there is a bunch of YAML files that describes a REST interface that a server can then implement. So now we have this abstraction. You don't need to pull in these custom libraries for each catalog type you want to integrate with. We've abstracted that through an API interface. And as long as a server implements that interface, now Iceberg can interact with it. And through this, we can have a single client talk to multiple different catalogs. And we're also shifting some of the responsibility of writing some of these files, these metadata files, to the catalog itself to do a bunch of resolution because it has that context. So I don't want to dive too deep into this because that could be a whole presentation, but you can see there's been an evolution, and a data catalog is paramount to using Iceberg. You can't really think about Iceberg without some sort of catalog. And Iceberg tables are probably not the only type of table or data that you have in your organization, which leads us to having multiple catalogs. So for your Iceberg data, maybe for your unstructured data, maybe for your random Parquet, CSV files. So inevitably, you end up in this situation where you have multiple catalogs, maybe a Hive, maybe an Iceberg REST, maybe Glue or more. And you need your engines to be able to interact with those catalogs to find those data sets and interact with them. So what we end up having is metadata is siloed and fragmented in terms of discovery, governance, auditing, and lineage, all those things that we were trying to achieve before. So now I'm going to take a moment to talk about Unity Catalog. Everything that I just said was sort of the motivation for Databricks creating Unity Catalog for having a multi-format, multimodal, unified place for your data. So what do we want? We want data managed, data and AI assets managed in one place. We want to govern those assets with a single source of truth, and we want to be able to leverage the best tools for your data, regardless of what data that is and what is the job at hand. So we aim to have support multiple formats. So that's your Delta, Iceberg, Parquet, CSV, JSON, all of that. A lot of these are not going away. We want to be able to support multimodal data. So when we talk about non-tabular multimodal data, these are your these are your like images, audio files, but maybe in the case of like AI assets, this could even be like hyperparameters and these like complex types of data. And then finally, we want the catalog to be unified, having a single place to govern your whole data estate. So if I had to draw a picture, it probably looks something like this. We want an open catalog to achieve that governance, discoverability, lineage, and observability across all those different kinds of assets. And by having an open catalog, meaning the way it's open to interact with, both for Databricks tools and engines, but as well as external tools and engines, by having an open protocol. So that's like the way the API endpoints that you interact with the catalog. By all of that being open, you can now bring the right tool and the right platform to your data to use and utilize. So now we want to bring all your data under one roof, and that includes Iceberg. So Iceberg at Databricks with Unity Catalog, what is that about? So we want to unify the Lakehouse with Databricks Unity Catalog. And what that means is supporting Iceberg as an asset within Unity Catalog. That's supporting writes and reads from any client. And the way that we do that is through Iceberg REST, as well as like Unity has their own open API spec. But by having all of this under one roof, you can now access all of your data with the appropriate clients. Also, having all this data under one hood means we can access and govern foreign catalogs that you might want to register with Unity Catalog. We have this concept of federation and mirroring. So inevitably, you will probably have these other catalogs that you have, maybe for historical reasons, but we want a single source of truth, especially when it comes to discovery and observability. So we can register those, we can federate those catalogs to Unity, so it can be the single place to govern the access and find and use those data sets. Finally, we want to break the format silos by governing all these formats under one hood. And I think the other piece of that's maybe interesting here that we don't really talk about too much is we have a service called predictive optimization. When it comes to Iceberg data sets, and this came from what we used to do at Tabular, one of the biggest features that we had at Tabular as part of our data catalog was all the maintenance operations. So this was your file compaction, your snapshot expiry, cleaning up orphan files. So you may be running these functions yourself manually in your organization. So we can take care of all of that for you in an AI-driven way to make sure your data sets are performing the absolute best that they can in minimizing storage cost. So these are the kinds of features that you can expect from Databricks and Unity Catalog. But I think more importantly, thinking like big picture is having all of this stuff under one hood. That is the real benefit, having that single pane of glass. So finally, I wanted to make sure I talked a little bit about Delta Lake. I think a lot of people have questions around like, what is the long-term vision? I think the long-term vision here is that we want to see a unification of both Delta and Iceberg. I think when you look historically at these two formats, they're trying to solve some of the fundamental problems we have when it comes to tabular data at scale, really large data sets in a data lake. Now, they've taken different approaches, but by partnering with these two communities, we can bring some of the best features of Delta to Iceberg, and same in the other directions, bringing some of the achievements of Iceberg into Delta. And we're seeing this happen in real time with contributions from Databricks to the Iceberg community when it comes to deletion vectors, for example, and variant type for semi-structured or unstructured types in these tabular data sets. So, and the other one I have here is also row tracking, aligning features like row tracking your changes within a table. So there's a lot of work that's happening here, and I highly encourage everyone to go look and follow what's happening in the Iceberg community and come to the Iceberg meetups. Yeah, so that's everything. I hope that was enlightening, and I'm happy to come again and do a talk on some of these concepts more in depth, but that's all I had. Thanks.